Dear students, once again we are going to continue with television receiver. And in the last period, we studied about how the picture raster is produced on the television screen by monochromatic as well as the chromatic signal. How television receiver and transmitter are going to be communicating with each other by using the block diagram of television transmitter and that of television receiver. In that, we studied that during the transmitting the signal, when camera picks up the scene, event, object to be transmitted and get it converted, its optical image into its electrical image, synchronizing pulses are added. We studied this aspect when we introduced the meaning of television communication and the role of synchronizing pulses which are to be introduced in the electrical signal proportional to the optical image produced by the camera by snapping the scene or event or an object. Those synchronizing pulses are used to synchronize the communication between transmitter and that of the receiver, so as to produce exact replica of the picture information on the television screen as it is scanned by means of a camera in the transmitter. Friends, today we will begin our lecture with the process in continuation with the process of the synchronization. Meaning of synchronization is to synchronize the transmission and reception with each other so as to produce the illusion of the picture on the television picture raster as it is snapped by means of a camera, and it is going to be gets converted the optical image into its corresponding electrical image. And to generate exact replica of the same event on the television screen, the synchronization is needed. Synchronization means to run transmitter and receiver in parallel to each other. Means whatever it is snapped by the camera, same it is going to be reproduced on the television screen. So that aspect we can call it as it is the process of synchronization. In short, by the technical words we can say same coordinates must be scanned at any instant on both, that is on the target plate in the camera and also the raster picture of the picture tube. If the same coordinates are not scanned simultaneously in camera as well as on the picture tube to produce the picture raster, the details are going to be spoiled and picture is not going to be reproduced as it is existing in the scene or in the event or in the object. And that's why the synchronization is needed. And to undergo this particular synchronization in the camera, during the conversion of optical image of the scene into its corresponding electrical signal, additional synchronizing pulses and blanking pulses are introduced for the purpose of the transmission, which are useful at the receiving end to scan the same coordinates which are being scanned in the camera, so as to give the exact illusion of same event, same scene on the television screen. And that's why the synchronization is needed. This is achieved by using the horizontal as well as the vertical sync and blanking pulses to be introduced in the camera and are separated at the receiving end, and then they are provided respectively to the horizontal and vertical deflection system to scan the same coordinates to produce the picture raster on the television screen to give the illusion of the same picture information which is going to be existing in the scene or in the event. So that's why the synchronization is necessary, and that is what one can understand the meaning of synchronization. Let us go line by line. Synchronization is essential that same coordinates be scanned at any instant. That is, for both at the target plate and at the raster of the picture too. Otherwise, the picture details will be split and gets distorted. To get perfect synchronization between the scene being televised and picture produced on the raster, sync pulses are transmitted during the retrace, that is, flyback interval of horizontal and vertical motion of the camera scanning beam. Means the sync pulses are introduced during the beginning of the retrace period of the picture produced on the raster in the transmitter as far as camera scanning beam is being considered. Thus, in addition to carrying the picture details, the radiated signal at the transmitter also contains the sync pulses. These sync pulses, which are distinct for horizontal and vertical motion control, are processed at the receiver and feed to the picture tube. Sweep circuitry, ensuring that receiver picture tube beam is in step with the transmitter camera tube beam. In color television communication system, in addition to these horizontal and vertical sync pulses called as color bursts are transmitted along with the horizontal sync as well as vertical sync pulses. These are separated at the input of chroma section and used to synchronize the color demodulator carrier to ensure correct reproduction of the color. Now, in the color chromatic signal transmission, in addition to horizontal and vertical sync pulses, color burst signals of 4.3 MHz frequency is introduced to distinguish between the monochromatic as well as the chromatic type of the communication. Friends, that's why the synchronization is taking place in the television transmitter and television receiver so as to produce the picture raster going to give us the illusion of the same scene or event snapped by means of an camera. Then how now we are going to study how exactly picture raster is going to be gets produced and what are the standards which are used to produce that particular picture raster on the television screen. The process of generating the picture raster as it is taking place in the camera on the television screen is known as scanning. In short, we can say scanning is a process that is used to generate the picture raster on the television screen as it is scanned in the camera for transmitting the signal. Means by scanning process, one can generate picture raster on the television screen so as to produce the illusion of the scene or event. Basically, there are two types of the scanning. One is the rectilinear scanning and second one is the interlaced scanning. In practice, interlaced scanning is being widely used, but to understand the interlaced scanning, it is very essential to understand the rectilinear scanning at the beginning. So that's why we are going to study a rectilinear scanning first and then, if possible, we will go to the interlaced scanning. Now, rectilinear scanning. Rectilinear scanning is used to scan the electron beam in a rectangular manner so as to generate a rectangular screen associated with the picture information. Now, rectilinear scanning is used to generate the rectangular picture raster on the television screen so as to produce exact replica of the scene or event on the screen of the television for the viewing purpose. To understand the meaning of rectilinear scanning, as we have studied while understanding the concept of television communication by using the block diagram of television transmitter and that of television receiver, we studied that in the receiver, the electron beam with high velocity containing the picture information having high kinetic energy after passing through horizontal and vertical deflection system, it is directly incident on the television screen and the television screen is coated by means of fluoroluminescence material. When the electron beam of high velocity incident on the fluoroluminescence material of the television screen, the material absorbs the kinetic energy, convert it into potential energy, utilizes that potential energy and produces a bright spot known as the pixel of the picture. This bright spot is now used to scan horizontally as well as vertically. Horizontally from left to right and vertically from top to bottom so as to generate a replica of the picture raster on the television screen. Dear friends, when electron beam incident on the television screen, naturally a bright spot is going to be generated. This bright spot contains the picture information and that bright spot will start moving from left of the television screen up to the right of the television screen. During this motion of the bright spot, that is electron beam, from top of the left of the screen to the right of the screen, it carries the picture information, and this motion of electron beam by carrying the picture information from left to right is with the slow speed. But when the spot reaches to the right of the television screen, it will start returning from right to left like this. But the returning electron beam from right to left is with a very high speed. Try to remember, when the electron beam moves from left to right, it carries the picture information. So that's why it moves with the slow speed. But when it reaches to the right, it returns to the left. While returning from right to left, it doesn't contain any picture information. So that's why it should be moved with a fast rate. And during this particular motion, the screen of the television is blank because it doesn't contain any signal. To avoid the waste of energy, waste of power, the screen is totally blank when the electron beam or spot moves from right to left. The motion of electron beam or bright spot from left to right is known as trace period, and the motion of electron beam from right to left is known as a retrace period. The trace period is with the slow speed, means it will take more time. Retrace period is with high speed. This retrace period is also called as a flyback period, or it is called as the flyback signal. Once the beam reaches to the left of the screen, again it moves with the slow speed from left to right, carrying the picture information. When it reaches to right, the retrace period begins, screen will be blanked and the spot moves to the right. Again it moves from left to right. Again from retrace period it moves from right to left. And this process of moving from left to right, also right to left, continued till the beam or spot will reaches from top of the left corner of the screen to the right of the bottom of television screen. Thus, the spot now arrived at the right corner, right end of the television screen. The scanning of the beam began from the left of the top of the screen, and it now reaches to the right of the bottom of the screen. When the spot moves from left of the top of the screen up to right of the bottom of the screen, one vertical scan is completed. Thus, during one vertical scan, 625 horizontal lines are scanned. How many lines are scanned? To reach the spot from top of the left to the right of the bottom, 625 horizontal lines are scanned. And we can say one vertical scan is going to be completed. Means the spot starts from scanning here and it reaches to here, where one vertical scan is going to be completed. Friends, first horizontal line will be start scanning when horizontal deflection system receives the horizontal bright spot is generated on the television screen, The current from horizontal deflecting plates increases from minimum to maximum in a sawtooth manner because the speed of motion of electron beam from left to right is less. Hence, this is because the current that flows through the horizontal deflection system will with a slow speed. When the spot reaches to the right, the current becomes maximum. And when this is known as a trace period. But when spot moves from right to left, the current starts decreasing in the horizontal deflection system. This is called as a retrace period. So during trace period, when the current through horizontal deflection system increases from minimum to maximum, the spot moves from left to right. And when current decreases in the horizontal deflecting plates, the spot moves from right to left. So this will continue for 625 lines. When the horizontal scanning system is initiated, simultaneously in vertical deflection system also initiated. Means horizontal and vertical scanning will takes place simultaneously. When 625 horizontal lines are scanned, current through vertical deflection system becomes maximum and the spot reaches to the right of the bottom of the screen. And after that, the current starts decreasing in the horizontal deflection system. It is called as a horizontal retrace period. Sorry, it is called as a vertical retrace period. Means first horizontal trace period and vertical trace period will begin simultaneously. After completion of 625 horizontal lines scanned, one vertical trace period is going to be completed, where we can say one vertical scan is going to be completed. And when current through vertical deflection system starts decreasing naturally, now the spot which is reached to the right of the bottom of the screen, now it starts moving to the top of the screen like this, and finally it reaches to the left of the top of the screen. This takes place during the vertical retrace period. And during this vertical retrace period, 40 lines are going to be gets wasted. Now remember, within one vertical trace period, 625 horizontal lines are scanned. But within vertical retrace period, it will take 40 horizontal lines to reach from right of the bottom of the screen to the top of the left of the top of the screen. Thus 625 minus 40, that is only 585 lines are active lines. Thus within one vertical trace and retrace period, one vertical scan is going to be completed. Means within one vertical scanning period, 625 horizontal lines are scanned. Out of those 625 lines, 40 lines are going to be wasted during the vertical retrace period, and that's why 625 minus 40, that is 585 lines are only active lines. Friends, at the every horizontal retrace period, screen is blank. So that's why at the end of every horizontal trace period or at the beginning of every horizontal retrace period, sync pulses and blanking pulses are applied to the horizontal deflection system to maintain screen of the television blank, as it doesn't contain any signal during its retrace period. That means the sync pulses and blanking pulses which are added in the camera tube at the transmitting end are now in the receiver end. Those are separated and those are applied to the horizontal deflection system at the end of every trace period or at the beginning of every retrace period, so as to keep the screen blank. Simultaneously, vertical sync pulses and vertical blanking pulses are introduced at the end of every vertical trace period or at the beginning of every vertical retrace period, so that during this vertical scanning also screen is going to be kept blank. Such 25 vertical frames are scanned in 1 second, so as to give the illusion of the picture raster on a television screen. Means within one vertical scan, 625 lines are scanned, and such 25 vertical frames are going to be produced in 1 second, so as to give illusion of the picture information on the television screen. Generally, scanning frequency, scanning time periods have some standards. Means within one vertical scanning, 625 lines are scanned. Out of that, 40 lines are vested during the vertical retrace period. Only 585 lines are going to be act as the active lines, so as to give you the illusion of the picture tube. Such a 25 vertical frames are scanned in 1 second. And this process of producing the picture raster on a television screen, especially on the rectangular television screen, where width is width is more than that of the height, is known as rectilinear scanning, that produces a rectangular picture raster. Friends, as we have studied that 585 active lines are scanned with the vertical resolution equal to 585 into 0.7, that is 409.5 lines, and horizontal resolution is equal to 409.5 into 4 by 3, where 4 by 3 is the aspect ratio. Aspect ratio is nothing but the ratio of width to height of the television screen, width to height of the picture raster. It is known as aspect ratio. 0.7, it is the scale factor. Means vertical resolution can be calculated by using the number of active lines, that is 585 into 0.7, that is scale factor, that is going to give you the 409.5 lines. And horizontal resolution can be achieved by multiplying the vertical resolution with the aspect ratio, that is 4:3, it is fixed, and that comes to be 546 lines, black and white alternately. Means out of 546, 273 cycles of black and 273 cycles of white lines are scanned. To calculate total horizontal scanning frequency, one can make use of number of horizontal scanning lines multiplied by the picture scan. We are aware that 25 vertical frames are to be scanned in 1 second, and that's why number of lines are 625 multiplied by the picture scan rate is 25. So 625 into 25, that comes to be 15,625 Hertz. This is the horizontal scanning frequency. Friends, try to remember all those are television standards which we are going to be adopting to generate the picture raster on the television screen. If you take the reciprocal of this particular horizontal scanning frequency, we can get the total period, and that's equal to 1 upon 15,625, and that comes to be 64 microsecond. Meaning thereby, look at here, this entire time is 64 microsecond. Out of this is the trace period. So this particular trace period is 52 microsecond, whereas the retrace period is of 12 microsecond. So within 12 microsecond, beam will return from right to left. But to carry the picture information from left to right, it will take 52 microsecond. So 52 microsecond is a trace period, 12 microsecond is a retrace period, or it is called as a blanking period, or it is called as a flyback period. During this particular period only, blanking pulses and sync pulses are applied. So out of 64 microsecond, in 12 microsecond lines are blanked in a retrace period and 52 microseconds trace period. Thus, the period of square wave is 52 upon 273, that is equal to 0.2 microsecond. That is highest fundamental frequency is 1 upon 0.2 microsecond, that comes to be 5 megahertz. So this is related with the bandwidth. So maximum frequency is given as active lines, that is 585, scale factor, that is 0.7, aspect ratio, that is 4/3, divided by 2 times horizontal scanning period, means it is 64 microsecond. If you do this, you will get the maximum frequency is 5 megahertz. So by using all these standards, one can produce the picture raster on the television screen. So this is how one can produce the exact replica of the picture of the scene or the event scanned by means of a camera on the television receiver at the receiving end. Friends, that's all about the meaning of synchronization and also the meaning of a rectilinear scanning. Next time we will study with the meaning of interlaced scanning.